This video is essentially how computers work. And essentially, computers work through logic. Logic can be split into information and processing. Information can be represented as zeros and ones. These are called bits. Bits in your computer are sometimes represented as 5 volts and 0 volts. In the hard disk, sometimes it's represented as a change in magnetism and no change in magnetism. Bits are used to represent numbers, words, images, videos, graphics, essentially anything that you see on your computer. These bits have to be processed. The most basic form of processing is Boolean logic gates. Simple Boolean logic gates include the AND gate, which takes two inputs and ANDs them together, the OR gate, which takes two inputs and ORs them together, and the NOT gate, which takes a bit and inverts it. These logic gates are built using transistors. Transistors act as switches in the circuit for current flow, and they are sturdy, small, fast, and affordable, and are used to create classical computers. However, quantum mechanics complicates everything. Quantum computers try to take advantage of quantum mechanical concepts. Quantum computers are built off of qubits. A qubit can have a state of 0, a state of 1, or a quantum superposition state of 0 and 1. So 0 or 1 or 0 and 1. This superposition state can be, when measured, collapses into either a 0 or a 1. So essentially, measuring a qubit changes its state. Qubits have been represented as the spin of an electron or nucleus. Spin up means a 1, spin down represents a 0. Qubits have also been represented as the polarization of a photon. Vertical polarization can be represented as 1, and horizontal polarization can be represented as a 0. These qubits are held in superconducting electrical circuits at very low temperatures. These low temperatures allow the qubits to have superposition states. Quantum computers also have logical gates. The simplest is the measurement gate. The measurement gate measures a qubit. For example, if the qubit is a 0, then it will be measured as a 0. If it's a 1, it will be measured as a 1. However, if it's a superposition state, then it will be measured as either a 0 or a 1. And depending on the original state of the qubit, will change these probabilities of whether it's measured as a 0 or 1. Other gates include the swap gate, which swaps two qubits, the Pauli X gate, which inverts a qubit, and control gates, which increases the quantum complexity of the system. The significance of quantum computers lie in, first of all, digital security. If two people are trying to communicate, they can do so through qubits and fiber optic cable. If someone is trying to listen in onto the conversation, they must measure these qubits. However, we learned in quantum mechanics that you can't measure a superposition state without affecting it. So, this person will not be able to hack into a system without changing the state of the system. The properties of entanglement and quantum teleportation have been used to demonstrate increased security through communication. Another important significance of quantum computers is in simulations. Quantum computers can exponentially process data better than a classical computer. So this has huge applications in the medical and cosmology fields, where simulations are used for research. The applications of quantum computers are endless, and I'm very interested in them. Thank you.